Good evening, everybody. So let us start our class. So I want to start by just reviewing our schedule. So according to our schedule, so this is your final exam schedule. So your final exam will be your section is 3, right? Okay. So 3. So this will be May 2nd. Okay, 6 p.m. to 8 p.m. If you are late, then you will not get extra time. Okay, so the class starts at 6:30, but the exam will start at 6. Please remind that. Okay, Michael, you will be fine.
So far, so good.
Okay, I wish.
2 days next day.
Okay, okay, I wish. Okay, and for the online section, we will open the exam between these dates, on 2nd and 3rd. Maybe the evening of 2nd and the midnight of 3rd. Okay, so please make sure that your schedule fits in according to your plan. Yes.
How much is it weighted compared to the other tests? Is it the same or is it more?
Almost maybe same. But if anyone has did not appear in any test, that we will cover the final. But there is no makeup for final because we do not personally schedule this. This schedule is made centrally. Okay, but if you have any conflict with your another final exam, please let us know ahead of time so that we can report to them. We cannot change them, but we can report to the registrar office. Okay, and then let me go back to our schedule. So we are at the end. So we have just left parallel processing and binary search tree. So from this topic you will get 10 or 20 points. Maximum 20 points in your maximum 10% to 20% point in your final. Not more than that, okay? So maybe one question from one chapter. Okay, so and then there is it's called C day, right? Is C day or NCUR day? So there will be no class from 11 to 13. So let us see that when 11 comes. Today is 9th, right? For Thursday there is no class?
Yeah, next Thursday.
Okay, there is okay.
For this Thursday.
Okay, so next Thursday we are not meeting. So, okay, I have to finish this. I have to complete this parallel processing tonight. Okay, that what I like to you everybody to do. Please review your test 1 questions, test 2 questions, and test 3 questions. You will get some similar questions from your test 1, 2, and 3. Okay, some similar questions. At least by this time, review those. And whatever you do not understand, please raise your problem to me. Yes. Maybe tomorrow. I have completed getting my part. There is another grader he is getting. Okay. Oh, and by the way, I extended quiz, although it's not added in the here. I extended lab 6A and 6B until tonight, midnight. It was 3:31. Then we extended a week and then another 2 days because I got email from some students that they were not. So we have only one more assignment left, right? Okay. And remember that there is no 7A. There is no 7A. There is no pseudocode for the 7. 7 all on the source code. Okay. So according to our schedule, we will discuss parallel processing. Okay. So nowadays, parallel processing is a common. Parallel processing is a common task, although we have been enjoying parallel processing in using our computers and laptops, even cell phones and mobile devices. Okay, so we discussed one of the first steps of parallel processing is multi-threading. We discussed multi-threading, right? In the multi-threading process, that we can have multiple threads, and the parallel processing comes from that concept that you can parallelly execute multiple threads at a time, or multiple, even a thread can be a small program, a method or function. It can be a small program, or it can be a part of a large program. So that depends on on your context or situation. So nowadays, even when you use your cell phone, you will see that all, even iPhones or Android phones, there is called, if you see the configuration, it will say there is coprocessor. You may hear the name coprocessor, right? Adjunct processor, additional processor. So most of the computer systems right now have coprocessors. That means multiple processors. So multiple processors are used for parallel processing. So if you like go back 10 or 15 years ago, is that compared to 15 years ago and now, and every year you see how fast the computer and mobile devices memory size is growing, right? Like 4-5 years ago, that you got a mobile maybe 32 gigabyte max. Now it is 1 terabyte. The price almost same, right? But even processor speed is growing fast, and also memory size and capacity is growing. So like about 60 years ago, in mid 60s, there was a scientist. His name was Gordon Moore. He predicted that in every year the transistor size actually it's called circuit size will be doubled within every 2 years or 4-5 years. The double means, in binary system. So in 1 gigabyte, then 1 means 2 to the power 0. Then 2 gigabytes, then going to 4 gigabytes, then 8 gigabytes, then 16 gigabytes, then 32 gigabytes, then 64 gigabytes. Like these were doubling, right? So that is called Moore's prediction law. So Moore's predicted that in every 2 years, the circuit capacity will be growing as double. And he predicted that trend would continue at 10 years, say, but still it is more than 50 years. But still that trend is true right now, right? So we don't know yet where it will stop. Gigabyte, terabyte, picobyte. I don't know why it will stop. So software developers are getting benefit from this trend of changing the speed, or also increasing the memory capacity, right? And the concept is that for our parallel processing, actually Parallel processing, the concept is that, sometimes there are some complicated operations like I'll give an example. Matrix operation. A matrix multiplication is complicated, right? For the matrix multiplication, you need to multiply each of the row elements by the second matrix column element, and then you will get one element of the multiplicated matrix, right? That takes some time. And also, for the easiest one, we know from our very kindergarten side. So if you are given a problem like 2.25.760, and then if you are given another decimal number, if you are given this decimal number, and if you are given another decimal number, like for very simple 550.2, for instance this, and if you are asked to even simply add these two decimal numbers, okay, this is not an easy task, because if we want to do this addition like this way, it will not work, right? We have to shift the second number, we have to make the decimal points aligned, right? We have to shift the second number, whole numbers, like 2 bits from right to left. For large number, that will take long time. And think about, for nowadays there are big data operation. If there are many hundred or thousands or millions of this kind of operation, okay, then definitely that will take some time, especially for this kind of decimal operation. So actually this issue raised even when I was a student 30-40 years ago, even 30 years ago. There was study about this research started about 30-40 years ago, and then computer scientists at that time, they decided we should have multiple processors. We should have a dedicated processor that will be used only like for this type of decimal operation or matrix operation. So if you closely look at the computer's configuration, that you will see that it will tell you that it has a coprocessor that has capacity to execute this number of instructions per second, very large number of instructions per second. So even each of the instruction, it's shifting 1 bit. So shifting this number is 2 bit. So it needs to convert that integer decimal number to binary, and then moving 1 by 1 bit, 1 bit by 1 bit. That takes some time. So the parallel processor concept came at that time. So now, in earlier stage, it's about 20 years ago, when I studied what is that called? Electronics, and the course I took, electronic course, that we learned 404 processor, very simple microprocessor, how they work, and their internal, we learned their internal structure, how the operation, the registers work. I don't know if you are taught that kind of very low level programming. We worked on it's called assembly programming language, that we used directly register to put whole data and then do operation. So what I'm going to tell you, that the coprocessor system is built since about 20 years or 30 years ago. That now every computers have at least 2 processors, The concept is that when you have a multiple processor, then you can do parallel processing. So then let us go in depth of these slides. There are few slides here, just 5 slides in the original lecture materials. So having a coprocessor or multiple processor have advantages that actually that are being used in designing current operating system. You know, the most of the current operating systems are uh, parallel processing operating system. We can, you know, at the time uh, we watch a website, we browse a website, we can watch some video, right? We can watch a movie, and parallelly we can listen to music, and parallelly we can print something, right? Or parallelly we can scan or execute another program or multiple programs behind. So these are possible due to the parallel processing. So this chapter is intended to give you just a concept of parallel processing. When you take senior level like special course for parallel processing or operating system course, especially operating system course, you will learn more in depth about parallel processing or multi-core processing in depth. You will learn. But just I want to give you just uh, some heads up, and then so that you can know, you can get an idea that it is possible. For instance, maybe before our last week, right, you did not realize that it was possible to have multiple threads in a program, right? Before last week, we discussed all programs that had only single thread, one main method, one main thread. But in our last week, we discussed how can we have we create multiple threads, another thread, right? And how can we execute multiple threads? We can execute programs with multiple threads. So in this program, in this maybe lecture, in the next half, I will give you just an introduction to and some basic idea about parallel programming. So actually, these were the 5 slides only. These were the 5 slides only in the original course content, but I personally added my own slides, and then I believe there had been added. Let me double check. Resource page and slide repo, and this one should be this one. Yes, you see at the end here, if you hover your mouse over here at the end, you see that taskbar says my initials. So here, this is a simple program of parallel processing. Okay. So what is parallel processing? I already discussed what is parallel processing. Parallel processing is a concept of processing, running multiple modules or multiple programs parallelly in a single computer. The concept of parallel processing is this. So if you have multiple processors, like here is called CPU, a processor is called central processing unit, CPU, right? A processor has memory, and it has in the core, it has is called central processing unit. It's called CPU1, CPU2, CPU3, and CPU4. If you have CPU1 to 4 CPUs, and if you have process 1, process 2, process 3, and process 4. Think about a situation if you would have only one CPU, then the single CPU would execute all of the processes one by one, right? For instance, if I had my only one CPU, then while running process 1, it may require something that would get from process 2. So at that point, process 1 would stop. Not stop, it's called maybe suspended, right? And would wait for the result to wait to start process 2. So that is called serial processing. So serial processing would take some time. And through parallel processing concept is that multiple processors will process multiple processes or programs or modules or applications parallelly. So most of our operating systems are multi-threaded and multi-parallel processing operating system. So the concept is that the concept is very simple nowadays. Although initially it was complicated to establish. Michael, so how many years ago that Starskin phone came? Starskin phone, how many years ago it came in market? 10 years ago? 10 or 12 or 15? Let us consider that is 20 years ago. Okay, maximum 20 years ago, the touchscreen phone and iPad or even touchscreen monitor came out, right? Think about that. Now it is easy. Even a small boy thinks that is simple. This is a glass, and I'm swapping using my finger, and I'm clicking on a button behind the glass. It should work, right? But think about the situation when the first group of people who did research started research on it, and who started this implementation. It was very difficult, right? It was very difficult. So taking initiative is sometimes very difficult. And when someone or a group of people take some initiatives, then other group of people easily can expand this, make some advancement, right? So like this way, when parallel processor comes with computer, then from the first version of Java came with a concept of thread pool. We discussed thread in last week. Okay, thread pool was the concept as a collection of thread pool. Actually, this is a concept of parallel programming, although it's a naive way compared to today's techniques. Although this was a naive way, that okay, a thread tool is a collection of worker threads that efficiently execute asynchronous callbacks on behalf of the application. The main use of thread pool was that used to reduce the number of application threads, okay, and provide management of worker threads. So we are not going to discuss in depth on this, but this is a concept that this is one of the advanced concept of multi-threading programming. Parallel processing was initiated from the concept of multi-threading. But think about a situation when there were many threads. Then at some point it was difficult to manage many threads, right? So from that point, the concept of parallel processing came. And then when the thread pool was added with Java, then it was convenient than multi-threading programming this way. Okay, that was the first technique although naive technique of thread parallel processing. And then later, the second and the better technology came with that is called executor service with Java. Talking about Java, maybe same thing for C#. Okay. So the executor service, this class gives some extra benefits over the thread class in Java. The concept was same like this. Let me are you able to see? Okay, the concept of this, that there was like multiple there was a thread pool on the right side, you see, and there was task submitters. It's called task submitters, and there was a task queue. So tasks were loaded to the task queue ahead of time, and then the tasks were sent to the thread pool. And this executor service used the thread pool concept, but this was a better concept. But very recently, a few years ago, that Java introduced another concept that is called ForkJoinPool. ForkJoinPool is the latest concept of parallel processing, parallel programming. So maybe in the next 20 minutes we can discuss a demo program with thread join pool. So thread join pool was more similar to the executor service, the previous model, but it was a little bit better. In the concept was like this: when there is a task is large enough to be splitted as subtask. A task was splitted into subtasks. It's called fork or split into subtasks. And if the task is again large enough, then it was forked again to make some subtasks. And when it became each of the subtasks became a small unit, then those subtasks are executed. Then they got individual result, and then those individual results are joined together. Those individual results are joined together to get the final or combined result. Okay. So that is the concept of fork join. So forking means dividing a task into some subtasks, and joining means joining the results. Okay, it is one thing that we should remember, that this parallel processing or parallel programming or even ForkJoinPool is applicable when when your task is large enough. Okay, for instance, in real life, if you want to move this desk, 2 people, 3 people, 4 people will be good, right? Will be better if you instead of moving alone. If you have more people, then it's fine. But for instance, if you want to move just one pencil from one place to another place, so it is very inconvenient that if you get 5 people to do that. That is inconvenient, right? To 5 people, work 5 people together to move just a pencil or a pen from one table to another table. That is not convenient way, right? Moving a pen from one place to another place with multiple people, that is doable alone, right? So that means similar thing I want to give you and remind you that when a task is large enough, then this process or multiple or parallel processing is doable or will give you a better result. But in order to do a very simple operation, this kind of parallel processing program will not give you any benefit. So the concept is more similar with, there is a well-known algorithm. It's called divide and conquer fashion, conquer algorithm. When you take algorithm class, you will learn about divide and conquer algorithm. It's well-known algorithm. The divide and conquer algorithm is like this. This is the pseudocode. Let me go back to the next slide. The pseudocode is very simple like this. So if you have a task, yes.
What if the individual tasks are somehow dependent on information from each other?
What is an task? A task can be a small method. It can be a chunk of methods, or it can be
Let's say one of the tasks requires getting information from
another task.
and that task
Needs
does
time.
they all wait to finish at the end, or if one can't complete without getting information from another task, how does that work?
Then we discussed that. This is called thread management. So that we discuss a little bit about thread management. So multi-threading programs have that concept included, so that there is no deadlock situation. Sometimes deadlocks happen even now. Sometimes your computer, in order to execute some process, it takes a long time. But we cannot wait, or we cannot be patient more than 2-3 more minutes, right? When you see that our processor computer is not taking my command 2, 3, 4, 5 minutes, we just restart or reboot. But there are some execution. If you do a Google search, that you will see that will take 1,000 years or even million years. So should we wait 1,000 years to execute a task? If you give factorial of a very large number, sometimes you see the computer will be working, but we will be impatient, right? Okay. So the first join algorithm is very straightforward, that we discussed. For instance, if we have a task T, and then place the task into smaller task, is reasonable number of smaller tasks. Okay. And for each of these tasks, solve that task. For instance, solve task I, if there are I tasks. And wait all tasks to be completed. And when all tasks are completed, join the individual results and then return the result. That is the concept of fork join. So ForkJoinPool has some advanced features. Maybe I will not discuss this, but let me. Okay, advanced features that for matrix multiplication, or some sorting, or tree traversal. We will discuss tree next week. For this some kind of complicated task, there are some benefits of this process. So let me go through this concept. Okay, Java's fork join framework structure is very simple. It looks very not complicated. There are two main methods over here. Important method. One is called fork method and another is called join method. Fork method is used to split a task, and join method is used to join the results. You should just give the attention to the direction. You see the direction. Fork, this is a task. Okay, so this is the opposite direction, the opposite direction. I want to go to quickly a program. So for instance, in order to do a Fibonacci calculation, Fibonacci n, or that means what will be the 10 Fibonacci numbers, or what will be the 100 Fibonacci numbers, or what will be the 1000 Fibonacci numbers, if we want to calculate these. Okay, so then I will show you shortly a program that uses fork join technology. So we know the concept of Fibonacci calculation by using a process called recursion, right? We discussed recursion. The recursion type, by using recursion method, it is convenient to find Fibonacci number. Although we can do it by using looping, but finding factorials or Fibonacci series and is using recursion method is convenient, that we discussed. So if I want to find the fourth Fibonacci number, okay, the concept is that the Fibonacci fourth will be divided into two forks. First one fork, it will get Fibonacci 3 and Fibonacci 2, and then Fibonacci 3 will be calculated, will be again forked as Fibonacci 2, and Fibonacci 2 will be splitted as forked as Fibonacci 1 or Fibonacci 0. So when we get the right side, Fibonacci 2, that this part will be replaced or reused when the program comes here. It gets Fibonacci 2. Because that right side will be calculated shortly, right? Quickly, right? If these two tasks start parallelly, then since the right side, at least one side will be completed quickly ahead of time. So that result can be used here. And then at this point, by using stack or recursion method, there is a join method. Here is, you see that these two lines, F1 and F2, this is the concept of making splitting, that means forking here. And you see the line before the return, number equal to F1 dot number plus F2 dot number. This is the concept of joining the results. Okay, so I don't like to go in depth. You don't need to go in depth. This program, I have this program in my GitHub account. I want to run it, and I want to give you some information. There's just an idea that how ForkJoinPool, how parallel processing is done in Java using ForkJoinPool. But I'm going to show you run this program shortly. But I'm telling you the secret is that there will be no, in your test, this will not be asked. Just I'm giving you an idea how we can do parallel processing. Okay, but it will not be asked in your test. So if you have passion and energy for the next 10 minutes, then I can do it. Okay. So the program is very simple. It's not a big, large program. Okay. This is this part. The last part, there is the integer method. This method was mainly discussed in the previous screen. And while here also in this part, the main method, there is an extra task to compare result, to see how actually the fork join technology work. Okay, before I run this program, if we run this, I want to discuss for instance something. If I run that program, it will give result like this. You see that? Okay, this maybe this will be a good time to give you an idea how we do write it's called console program. We can write console program. Please give attention for the next maybe 15 minutes. Okay, you will learn something new today. Okay, before I show that, but I'm explaining the output over here. You see that here at this time it will show that different times this program took. In the first run it took 16 milliseconds. In the second run it took 7 milliseconds. In the third run it took 5 milliseconds, and in the fourth run it took fifth run it took 8 milliseconds. For that is for executing the same program. Just I executed the same programs. Okay, I got the Fibonacci 20th Fibonacci, that is 6765. 20th Fibonacci number, okay, is the 6765. That is computed. That took sometimes 5 milliseconds, sometimes it took 60 milliseconds. The concept is that because sometimes it was splitted nicely, effectively, and sometimes it was not splitted effectively. Because there are two split. Initially there is two split. If it happens a random split. Okay, that for instance, if one side goes 19, if 19 and another side goes if for instance 1, then still it will take long time, right? But if one side takes 10, another side 10, that would be completely low time. Splitting, it depends. Since my splitting was random, so I did not keep any control. If I split it, if you play sometime maybe when you take advanced level course in operating system, you will get assignment like this. At that time you will remember me. So the concept is that this program takes different time based on its internal forking, how it forked. If the fork was efficient, then it took long time. This is small time, minimum time. But if the fork was inefficient, then it took maximum time. Let me show you. My program is available on GitHub. Let me check if it is available, is downloaded or not. Okay, ForkJoinPool. Okay, fork join parallel processing. Maybe this program, just different name. Or you can check GitHub. Okay, this one. How many of you started using GitHub? Okay, if you really start using GitHub, then you will be one step ahead. Even you see that compared to many senior students, or even maybe some graduate students, they don't know it. But if you use it, then you will be one step ahead. Okay, so this program, okay, very simple program. Okay, the same program. So I do have it over here. So let me go quickly to this folder program. CD src dir/p. Okay, you see that I have my okay, nth Fibonacci dot Java. Okay. Okay, this is the program for join. So nth Fibonacci. Okay, so it has a main method. Okay, this is a main method, but this is a command line argumented program. You cannot run this program here. If you run this program here like this way, you see that I'm clicking on run. Okay, sorry, my computer is not responding. Okay, did I get any expected output over here? Okay, it says array index out of bound exception. So actually this is a command line program. It will not give output like this way. If you run this program from here, it will not give you a result. Okay, so we need to run this program as command line. So this is another program type. So in order to do, okay, one thing that remember that in order to do command line application, in order to build command line application, you do not make any what is that called, package over here. Just put your code in the default package, because putting this code in another package will take something to do. That will be difficult for you. Okay, so this is a program. So you know, so remember that I first time like 20 years ago, when even I wrote my first book on Java programming, I compiled all of my programs like this way. At that time there was no Eclipse, there was no NetBeans, even there was no Notepad++. Only I use Notepad. And then later I found that using WordPad was convenient, that for copying and pasting. Later I used WordPad. So Notepad and WordPad I used. So it was difficult like this way. So this program is written. What is the method name? N Fibonacci, right? This is my class name. Then how do I run this program? I need to compile this method. How can I do that? I need to Java compiler. Then I need to put this name. Okay. Shift insert dot Java. Okay, this is the command to compile a Java program. Java, then you will write the class name dot Java. Okay, you know that, and let me show you. This is the class name. This one is the for now let me rename this one. I don't like to delete it. Let me rename this one, put this in a different name, and I want to show you what happens when I execute this command. Okay, give attention to my screen, please. What will happen, you will see that what happens if I execute this command, it will create this N Fibonacci class file. You see that this is the class file. It will create this one. As soon as I run this, you see that n Fibonacci class was created, right? Okay, now you will use that class to run your program. What is the format? I need to understand my code in order to do that, to run this program. It says my argument 0 will be my nth Fibonacci, that which Fibonacci I want to execute. And the second argument will be how many times I want to execute. Let us consider that we want to execute the 20th Fibonacci. The first Fibonacci number is 1, second one is 1, third one will be 1 plus 1, 2, right? You know, who knows the Fibonacci series? You know. Who knows the Fibonacci series? Fibonacci series is like this way: 1, 1. The third number will be sum of the previous two numbers. So third number will be 2. Then fourth number will be, go ahead please, 3. Then fifth number will be 5. Then the next number will be 8. Then next number will be 11. Then the next number will be 19, and so on. Okay. So for instance, in this way we want to find the Fibonacci. Okay, so there is a two groups of opinions. Some people say that the 0 is the first Fibonacci number, or some people say that 1 is the first Fibonacci number. Okay, so for instance, in this way we want to find the 20th Fibonacci number or 120th Fibonacci number. Okay, so this program, we will run this program. Let me see. So here in my command line, you see that then the command is Java. Now I will use Java. Then actually if I press up arrow, then it will come here, Java, and then my class name, I don't need to put class, and then for instance I want to compute 20th Fibonacci number and maybe 5 times. So then if I press enter, you see that it is running. This program gave me, first time it took 52 milliseconds. The same program it took second time 6 milliseconds, and it takes another time 55 milliseconds, and even one time it took 3 milliseconds. Because it depends on how the internal split was done, forking was done. So even if I run this program again one more time, it will give a different result. I don't know yet. Even if you see this time it took 100 milliseconds. So let us compare. If I want to get second Fibonacci number 5 times, the second Fibonacci number is 1 here. First Fibonacci, okay, let me do the third Fibonacci number. Okay, third Fibonacci number is 2, right? Let me do it this way. So the Fibonacci number, we got 1, first one is 1, second one is 1, and then third one is 2, and fourth one is, Michael, go ahead please, 3, and then 5, and then 8, and then 11, right? So 11th is 1, 2, 3, 4, 5, 6, 7. So 7th Fibonacci number is 11th, right? 11. So let me run this program again. Let me run this program. 7th Fibonacci number. I want to make maybe 4 times. I want to run maybe 8 times. Okay. The first argument it takes which Fibonacci number I want to compute, and the second argument takes how many times I want to compute. So it computed 8 times. So the seventh Fibonacci number is 13. Okay, and then sometime it took 8 second, 8 millisecond, 2 millisecond, 2 millisecond, even 1 millisecond. Okay, so this program is available in my GitHub account, but for now you will not need it. But sometime if you study computer science, you will need it. So then come back to my code, and then maybe at that time you will understand. So here in this code, actually I used timestamp in order to measure how many milliseconds it took to complete the program. So here this part, even if you do not understand this part, this part is the fork join here, and this part we applied fork join technology here. This compute method is one of the important method that is used. Compute method, somewhere just called compute method. You will see that this compute method. You see here Fibonacci. This is forking over here, and integer Fibonacci another time. Somewhere where invoke. I did this long time ago, so I don't have any practice. Okay, so this is just an example, a short example, very tiny example, but this is kind of parallel processing. So according to my course content, I have covered this parallel processing for today. Okay, you don't need to memorize this program code, but if you understand this, then it will be good. You can practice it. Okay, and in our next next Wednesday, Thursday, we don't have any class. Okay, due to our schedule. Remember that. Let me go it again. So, but you are encouraged to join in the conference. Sometime please join in the conference. So next Thursday we are not meeting here. Okay, so there is no class from 4:11 through 4:13. So we will get only 4:11. There is no class. And next week we will discuss binary search tree, and that will be our last topic. But meanwhile, I will post some questions on discussion topic. Some old question on the discussion topic. Please join, participate in the discussion, and I like everybody. Please practice from your previous test. Test 1, test 2, and test 3. You will get some questions repeated, similar questions from your previous test. Okay, and you will get one question from stack, one question from QE, and one question from linked list. Okay, so all of my courses are available in the GitHub account, but please do not memorize. What happened that in the last recent test, I was grading that. While I was discussing in class, I named a field as top, head, node top. But in the test, I gave the node head. But I got still some answers, they use top. Top equal to top dot next. That means, why did they get top? That they just memorized the code. We did not give any point on that one. Okay, so please, what else for the next time, I like you. So bring some questions, okay? Whatever you do not understand, please raise that. We can make, even if you like, we have maybe 2 more weeks, right? To you, I can review whole thing. If you get interest and energy, even I can review the whole thing in one sitting. I know that. I know everything once and out. At the beginning of this class, I told you that I know everything. But one thing that in the beginning I went very slow. Maybe some of you become frustrated, right? Some of you become frustrated. Oh, maybe the teacher would not be able to complete the course on the right time. But I knew that I would be able. And I thought that my philosophy, my goal was to start with a strong foundation. So this is why I discuss inheritance, polymorphism, abstraction, interface again and again. Even I will, after next class, I will repeat that again. Those are the foundations. If you go for interview, you will be asked that type of question only. You will not be asked to write a full program like this. Nobody will ask you. Unless you go to for a job for Google or Microsoft or something, nobody will ask you to write a whole program. But people will ask to see your concept. Anyone has any question? Okay, even if you do not have any question, please give me your opinion, so that I like everybody to do good, at least to get B in this course. Okay, thank you so much and have a good evening.